So this title is erroneous. It should say bringing probability to the learner, not statistics. So that's my mistake. And it's really interesting that this kind of idea of motivating students who maybe are not there by choice has come up over and over and over again this conference. On Monday, so he was talking about how students' attitude towards statistics is one of obligation. And on Wednesday, I heard from Nushin, who talked about life science students and used a picture of Grumpy Cat to represent their how they thought about statistics. And even yesterday, Mike Smith was talking about the importance of letting students choose topics that they care about when they're doing their work with data or whatever they're doing. And so I thought I would talk about that for my talk. So again, just if you like to play along at home, I'm going to ask some questions about your own classes so you can think about what I'm saying, and starting by thinking about why are students in your class. I'll talk a little bit about the problem that we faced at Waterloo, specifically with our computer science students. So this relates to what Amy was just talking about as well, the computational aspect, and how we started a pilot program to address that. Talk a bit about how we improved it gradually over time rather than trying to tackle it all at once, and some results, both qualitative and quantitative, from the pilot. So to start off, thinking about why are the students in your class? If you have a course where you have trouble reaching and motivating some of your students, or maybe all of your students, you want to think about what the context is. So is your course a requirement for them? Is it an elective that they're choosing to take? Is it a mixed population where some people in the course have to be there and some choose to be there? Because that's going to be, it's hard to serve two different audiences at once. Is the course restricted to certain students, or is it open to anyone? How does it fit in with their overall academic progression? Is it going to, or future courses going to rely on it very heavily, or is it kind of a one shot where they don't really see it again later in their courses? Or maybe they do see it again, but not for several years. And also, is it related to their career or what they actually like in their personal lives? So all of these things to think about when you're thinking about how to motivate your students in your course. So the issue that we had at Waterloo, I'm just going to introduce a little bit about the course. It's called Stat 230, very similar to the course that Amy recently described. It's a required course for actually all math majors, and that includes computer science majors. That's in the Faculty of Math at Waterloo. And it's huge. It's typically 500 to 1,000 students in multiple sections usually. And it's usually taken in the second year, or sometimes for really strong students, they can take it in the the second half of their first year. Generally, we saw that CS students in particular didn't really see the relevance of probability to their chosen major, and they typically underperformed. So their average was lower in this course, more so than it was in other math courses. So they're generally reasonably strong students, as strong as any math students, but their marks were depressed in the Stat 230 course. So we had an idea. We bandied around lots of possibilities, including having a separate course just for the computer science students. That was quickly shot down by the computer science department. So we settled on this, which is to just have the same course, but a CS focused section of the course. So we would just pop all the CS students into one of the sections. They would have more CS content in the lectures, but the same tests, exams, quizzes, and all of that. So it's the same course. They just have, we spent the class time on applications that would be more relevant to them. And our hope or our desire was that seeing the relevance of the material to their chosen major and to their lives and to their interests would improve their engagement and improve their performance. So how do we do this? I didn't get any extra teaching credit to develop this new section. It was just, they asked who wants to do it. And I said, ooh, me. I'm married to a computer scientist. Lots of my friends are in computer science. I got lots of ideas for how to sort of make the material more relevant to the CS students. And so we just gradually added stuff a little bit at a time each term that we did it. The first time through I did it, I added a few CS examples to my classes, try to think of at least one per week that was very, very CS related to tie into the material. And so I would just replace a problem about drawing balls from urns with a problem about accessing items from a database. Like you don't need to make huge changes to the examples to make them more relevant. We also had some CS flavored questions, again, like rather than looking at just like a list of people sitting in a row in chairs wearing different colored hats or something. Instead, it would be like the leaderboard of Pokemon Go, and like which are they, like Valor, Mystic, or whatever, just like relation or examples that related to the things that they were interested in. We also introduced a game of the week. So I asked the students what games they like to play, and then I would find one that related to the course material. So on Fridays, we had the SWAG, which is the Statistics Weekly Application to Games. They came up with that acronym for me. So we just had our weekly game application. And so we talk about things like, how to count cards in blackjack, or various game related things. And we also introduced a little bit more R. I'll talk more about that later. The next time I taught the course, we relaxed the restricted enrollment. So we didn't require CS students to take the CS section and require non-CS students to take the non-CS section. We kind of suggested that this is what they should do and just let people freely move between them, just to make administratively things a little bit easier. We had a few more examples that I'd added in, and we actually took many of the CS examples and CS flavored questions that I had created and added them to the course notes. So they were now there, part of the course notes for all future students. So we don't have a textbook, we just have a set of course notes that have been developed, and we just keep adding stuff to them, so adding more computer science examples. The next time I taught the course, machine learning was a big request for a lot of students. There are a lot of them interested in it. And so I introduced a machine learning idea of the week, which I don't have as cool an acronym for. So if anyone has any suggestions, please let me know. And so that would include things like various algorithms that are relatively easy to understand. The idea of a naive Bayes classifier just uses Bayes rule. So we talk about that in the week that we do Bayes rule. When we do the multinomial distribution, I talk about the bag of words algorithm for document content analysis. So there's lots of, we're not really getting deep into the machine learning, but noticing the ideas and the principles that underlie some machine learning concepts, we can get those out to the students right now in second year. And they really see that that's really relevant to their future careers. I also had, there's a great sci-fi story that has some stats in it. So I read that and I talk about the ethical use of data as well, because it's always good to slip in some ethics into your stats. I want to add one more, an unexpected step 4 for this process was when everything moved online. So we kept most of the same things. We did, even though we had a huge number of students and 4 instructors, we kind of gave each student a home instructor that was like theirs. And so we just gave all the CS students to one instructor. Mostly people just interacted through the discussion forum anyway, but it was just like a signal that, like, yes, there is a CS section of the course still. We had some thought question polls on our discussion board, which we used Piazza for. So every week there would be usually about 3 questions about the course material, and it was a poll, and all you had to do was answer. You didn't have to get it right to sort of get the credit. And that led to some really, really interesting discussion. So sometimes they were open-ended questions as well, like how does this statistics or this probability concept apply to your life? And people would write in answers. So that was really neat. I also really, really wanted to keep my swag and MLIW components. So I did a live stream for those every week. The Stat 230 course online is entirely asynchronous. Normally there is no synchronous component at all. So this was something that I wanted to do just to have that interaction. So I had a live stream every Friday and people would tune into that. And I chose the platform Twitch on purpose. So it's not an academic platform. It's a gaming streaming platform. That's what it's primarily used for. And so the audience that I was trying to reach, that's where they would be. So I go to them. I could have used the built-in, we had Bongo as our thing. I could have used Microsoft Teams, which is the official University of Waterloo thing to use. But I wanted to go where they were and go into their world and be there. So I recorded them through Twitch, and actually also then posted them, because Twitch isn't accessible from everywhere in the world, posted them on the course website. And they're actually freely available. You can visit the YouTube playlist there if you like. So that was mostly for swag and the MLIW, but also if people were there, they could ask questions. And sometimes I do like advanced R code and stuff, and teaching people how to write their own functions and stuff, using recursion and loops and all sorts of fun things as well. And then we did have as well computational assignments, which, as Amy was describing them, they reminded me so much of mine. I was getting nostalgic. So we would do very, very similar things. So like have an analytical part where they would, theoretically calculate this probability, and then use their student ID number to set the seed of a simulation. And then, so we can tell if they didn't do it, and then simulate and then compare their results. And we very, very purposely chose examples that were probably relevant to their interests. So we had one question about COVID testing, the reliability of that. We had a question about Dungeons and Dragons. So we pretended that the 4 instructors were all playing a game of Dungeons and Dragons, and each of us had a different attack that does a different amount of damage, and then simulate the battle and see if we can defeat the monster in one turn. And then also a question about looking at correlation, where we had the GameStop stock short fiasco was going on. So we made a question out of that. So that was just another way to kind of take what comes and bring it into the course. So I would like you to think about your course that you're teaching and think about how you can gradually make changes to it. So again, you don't have to do all of this at once. If you had told me when this pilot started what my course would look like now and said, you're going to do all this with 0 additional teaching credit, I would have ran away as quickly as possible. But because it was iterative and each time you're adding a little bit more, you could end up creating a really, really valuable experience for all the students with just a little bit of work each time. And so I want you to think about one change that you can make in your course right away, the very next time you teach it, and maybe one thing you can make in the future farther away from now. In terms of where to get inspiration for ideas, I got a lot of inspiration from my partner and my friends that are in computer science. I reached out when I first started this project on Facebook and said, hey, people in computer science, what do you use now that you learned in Stat 230? And answers of nothing are not acceptable. And I got over 100 responses from people telling me things that they've used or things that were relevant. So I was able to tell my students, look, people who are now working as computer scientists, like they're software engineers, they are telling you that they have used this stuff later on in their careers. So it was really great to be able to sort of point to that. But also, did some research, looking up stuff on my own, learning new things myself. What's in the news, keeping track, there's always stuff going on that you can turn into questions. What the students are into, ask them. They have lots of examples of things that they care about that are popular at the time, and you can incorporate that into your course design. So again, for those playing the home game, think about your course and what can you use or who can you reach out to for inspiration. This conference, of course, is a really great way to meet people and get inspiration from what other people are doing. So I want you to think about writing down one person that you can go to for ideas, again, whether that's a partner, a grad student, someone you met this week, colleague, whatever, and one resource that you can consult for ideas. Again, whether that's knowyourmeme.com, honestly, that's a great way to find out what memes are popular, and you can try and incorporate something relating to that into your course. But the news or whatever, Reddit, whatever, anyway, lots of ways that you can reach out to resources for ideas to incorporate into your class. How's my time? Okay, halfway done. Fabulous. So I want to share a little bit of the results that we had after 2 or 3, I can't remember which, terms of this pilot. We did a student survey, and I have some qualitative results, just the kind of things that people, it was two terms of the CS section, which comprised 3 sections. People mentioning that they liked seeing the connection of how it was going to be useful. They just appreciated that we were considering their needs and catering to their degrees, the recognition that they might have different priorities, and in the in-person sense, just like having their peers be there. And so they knew that they had common touch points that they could relate to, and that they might all be struggling with the same assignment for a computer science course at the same time. And so just creating that community of learners kind of feel. So they really had a lot of great things to say about the first couple of terms of it. And they also had lots of really great suggestions for new problems that I could then incorporate the next term. So some of my favorite examples were suggested by the students from this survey that I was able to incorporate into later terms. So it was really, really great to get that sort of qualitative feedback. We also have some quantitative feedback. So again, this is survey results from after the first couple of terms. Not overwhelmingly positive, but most people agreed that they found the topics interesting and that they should continue to offer the CS section of Stat 230. In fact, the most common request I got was that you should do the same thing to Stat 231, which is the statistics course, the follow-up course. Nobody has taken that on yet, but maybe there'll be some momentum to get that going as well. A few said that they were more interested in thinking about taking upper year statistics courses. Not a huge number, but that's okay. Yeah, it seemed like a relatively good response to the program. And then finally, that when the chips were down, we want to know how much impact it had on the student grades. So this is after several more terms of having the CS section. So I think this is looking at several years of data altogether. In terms without a CS section, we can think about the average, the mark distribution between the CS students and the non-CS students. You have the numbers there. And the mean, the difference in the means was a gap of 4.2%. Waterloo doesn't use letter grades, we use numbers. So that is highly, highly, highly statistically significant. I forget exactly what the p-value is, but it's astronomically small. So that was in terms with no CS section. And in terms with a CS section, we can't just look at the grades because there's a confounding factor, of course, with, the exam might have been easier or whatever. So what we're going to do is look at the gap as well between the CS students and the non-CS students. And this is, again, after several terms of some terms having CS sections and some terms not having CS sections, many of the same instructors, and just different configurations. So what does it look like now? Ta-da! We end up with a gap between the grades of only 0.9%, so it shrank from over 4% to under 1%. It's no longer statistically significant, and we seem to have basically succeeded in closing the performance gap between these students, which is what we set out to do, to try to motivate those computer science students to realize that, yes, this course is something you should care about, not just be there by obligation, not just be a grumpy cat, and actually see that relevance to their own lives, and thus perform better. So, for yourself, playing along at home, think about your course. When you make changes to it, how will you know that it's actually working? So I want you to think about one goal that you have for any change that you're making to your course, any kind of intervention, and then one idea for how to measure the success of those changes. You could survey the students, you could look at the grades, you could, do things formally or informally, but it's nice to be able to quantify how well you're progressing towards your goals, and you can't do that unless you have your goals laid out in advance. So anytime that you're making any change, I would encourage you to think about what your goals are and how you can maybe measure the success of those changes. All right, just lastly, to summarize some of the lessons that I learned throughout this whole process is that you really don't want to do everything at once. A giant overhaul can be done, of course, but that takes a lot of effort and resources, which you may not have or your department may not have. So starting small, just adding one new thing and kind of snowballing and iteratively improving is a really great and effective way to make changes to course design without needing huge amounts of resources or approval from various other sources. You definitely want to get feedback on how it's going from the students and suggestions about what's working well, what's not, and they can be really great sources of inspiration for new ideas to incorporate. And if you do create this new material, roll it into the course material, just like Amy's doing with her R supplements, so that all future students will benefit. You don't want to create something that as soon as you stop teaching the course, disappears. You want to have something that's sustainable so that it will outlive your own involvement in the project. So I haven't taught Stat 230, or I went a good year without teaching it, but the CS section still continued without me because those resources were all there. And of course, now that we're had this year or bit of teaching online, when we do go back into person, think about using any digital assets that you created. Don't just throw them out and go back to the old way of doing things. Make sure that you're using those in an effective way to keep the good stuff and keep the benefit of the pandemic teaching that we've all had to do. So that is everything for me. This is my contact info. If you want to follow me on Twitter, I'm at AxiProf, and I have a teaching blog where I write about lots of different teaching things that I do. And so check me out there. It was lovely to be here, and I think we have a few minutes for questions still.
Thank you so much, Diana. Any questions from the audience? I have to tell you, one of my favorite books is Small Teaching, James Lang's book, and the idea of there's no need to do a huge overhaul, but just make small changes, hopefully based on evidence of what works, if you've got the evidence. If not, what even experience is evidence, and see and see the changes they make and reflect and then go on with more changes. And that's how teaching change really happens. And I love that that was part of your practice, and that made the difference in your course. Something else I really liked about what you were just saying is for a short time I taught a stats course that was designed for computer science students. And I found one of my challenges was finding examples that would be relevant to the computer science students that weren't just toy examples. So I really, really love that you reached out to computer scientists and got their input. Did you find that you had any trouble with getting feedback from them or problems from them that you had to simplify in order to use with your second year students?
Yeah, that is true. So you do have to make some simplifying assumptions to get it to be something that's mathematically tractable. And so you just have to be honest about that. Like, if you're going to use a Poisson process to like talk about emails coming into a server or something, it technically doesn't satisfy the conditions. Or if you're going to talk about like using a cache for a website, like how long does it actually, how much time does it actually save having the cache or not having the cache? You have to make up some stuff and simplify some stuff, but I think that's okay. Like, I mean, the same is true for relatively toy examples too. Nothing is perfectly a Poisson process, even though we like to pretend it is sometimes.
Yeah, fair enough.
I see a hand up.
It's Amy. Go ahead, Amy.
Okay, so first, thanks for the talk. It was great. I also see there's a question in the chat for after me. So when I sort of worked through incorporating all the computation, I learned from it that, I needed to be talking about it more. And so that was something I didn't do that I needed to be doing. And I was just wondering if there's anything that you did that you either found didn't work or something that you would tweak further or something like that.
That's a great question. I feel like compared to your approach, we threw our students to the wolves. We gave them no instruction in R whatsoever. And it was just like, not none whatsoever. Like we provided some handouts and stuff, like a little like mini tutorial, and like 5 minutes of one of my live streams one week was like, this is what our studio looks like. This is how to debug, go. So we basically threw them to the wolves, and their first computational assignment, they were like, oh, but then they were fine. So we were more in this, like, if your little pyramid of like instructor involvement and student responsibility, we were way on the opposite end. We were just like, yeah, they'll figure it out. And most of them did. So I think maybe there's a middle ground to be reached. So maybe having a little bit more direct instruction in terms of R, but particularly for the computer science students, they would have hated it. If I tried to tell them how to code, they would have been like, yeah, I know how to code. So providing the resources and making them available for those who need them is maybe the right balance to strike. Thanks for the question. Yeah, the question in chat though that I just see is, do CS students require to use Python instead of R? We just had everyone use R because it's easier to have everybody use the same thing in terms of grading. In other courses that are more advanced or maybe smaller, I usually just say you can use whatever language you want. R is the one that I know best, so I can help you with it. But if you want to use Python, you can. And I did sort of, if people were interested in Python, there was lots of opportunity for me to sort of like provide enrichment of like, say, if you're interested in this, here's a link to Python. But in terms of the formal assessment of the course, in terms of like the course content, it was only R that we required them to use.
Do they come in with Python from first year?
No, they use something else. Actually, it depends which track they do in first year. I think some of them do Scheme, and some of them will have seen C++ by then. And
it's Waterloo.
Who knows? But yeah, that's the thing. Like, if you know one programming language, it's infinitely easier to learn any other because the principles are there. Like you don't teach the language, you teach the principles. And so R and the syntax of R and the documentation of R is so extensive, and the syntax is so logical that it's usually very, very quick. When as soon as I show them how to do a for loop or something, they're like, oh, that's it? Okay, easy. The syntax is much more forgiving, I guess, and much more intuitive.
As long as the students don't get frustrated. I find some computer science students don't love R, but Sohee, go ahead.
Hi, Diane. Thank you so much for wonderful talk. This is amazing. And I just have a quick question that when you compare the grade for the new computer science students, and it seems like, so they are writing the exactly same test, like your group of students. So, and then one of the so this one, it's include the COVID time, or that was the in-person classes only?
This is all pre-COVID. So yeah, this is
Pre-COVID.
all pre-COVID data. Thank you for asking because that would be confusing otherwise. Yeah.
Yeah.
So I believe it's 3 or possibly 5. I wish I had double checked years worth of data. And so of course Waterloo has 3 terms a year. So that's a lot of students overall. And it's not just all of the no CS sections happened and then all of the CS sections happened. There was mixing in between. So some summer terms, there was no CS section, and then some winter terms there was, and fall terms there was, and sometimes it wasn't. So it just depended on who was teaching it, whether there was someone with enough expertise to pull off a CS section, basically. And so when they were happening, they generally did better. And so it's kind of neat to see the impact of it. But yeah, it could be confounded with other things. Never ask a statistician for an unqualified answer. It could be confounded with other things, but I think it's a pretty significant difference here that looks like it is making a difference.
Yeah, so it really wonderful to see the impact of the change course material can impact the students a lot. So actually we are thinking about that too, because we have a lot of computer science students and they really didn't like probability. So we are thinking about we make it a separate section. So it's completely different, like they have a different course code, so that it's going to be different assignments and different exams. Because one of the students' evaluation, a survey that you did, seems like students want to have a different exam than non-CS students.
Just to clarify, let me go back to that one. It's actually very few people wanted different tests. That's only 20% wanted different tests.
Oh, I see.
But yeah, sorry, these colors are not, this is the default template for Waterloo math slides and it's not great. So yeah, it wasn't, the fairness, I think, because they'd be worried that like, oh, maybe they'll be harder if they're different. And so our original idea was to have a separate course for CS students, but the CS department really didn't like that idea because they didn't like the signal that it was sending, that like, oh, these CS students are just so dumb, they can't take the real stats course, so we'll make them a different one. And like, that's not at all what we were saying. We were saying, we think they're as smart as math students, they're just not engaged with this course material. And so this was kind of a compromise that I think worked really well, to just, the signal is, it's still the same course, we think you are capable of it, but we're just giving you extra motivation to reach the potential that you clearly do have, which is the same as all the other math students. It was a little bit of a political issue, and so I don't know how your relationship is with your computer science department, but if it's friendly, then something like this can work really well. And occasionally that might happen where we start off like this with just a different section and the course ends up diverging so much that it becomes clear that actually, yes, having a different course code would be the right thing to do. And that has happened for some of our math business courses. Like we started off with it splitting the sections into one majors and non-majors. And then it ended up being like, oh, okay, wow, they're both doing much better when they're separated. And so it became 2 courses. So that could be a long-term thing. Although I kind of like having everyone together because it is nice.